Calcium chloride, the CaCl2. Can somebody give me a qualitative observation? Ali, qualitative observation for calcium chloride.
There's like these small, tiny
Small, tiny pellets. Small, tiny pellets. Okay.
White.
Excellent. Obviously, white. Yes. Perfect. What else? Did anyone feel it?
Yes.
You right back there, Katie?
No.
Did anyone feel it? What do we call it when we feel something? It's
Texture.
good. It's texture. What's this texture, Andy?
Rough.
So it's kind of rough, not smooth. Anything else we can add about the calcium chloride, the CaCl2? Funky smell. No, we can't say it has a funky smell. We can say it has a odor, right? Because that's opinionated. I could think it smells good. My mom thinks it smells bad. So it has an odor. Tyler, you want to add anything? Okay. Baking soda. The sodium bicarbonate. Gabrine. What's that? Looks like a drug.
How would you know that?
Yeah, well, that's probably. Oh, I don't know if that's prior knowledge or prior experience. I don't know. So, can we say it looks familiar? I can't write down. It looks like heroin up there. I don't. Like if Quasi walks in, I
This
write
doesn't
this
look
down.
like heroin. It looks like
Yeah, this is
cocaine.
not bad. It looks like cocaine.
Jared,
Is this chlorine?
what's that?
Is the little pellets chlorine?
Is it chlorine? No. Yes. Is there potential chlorine in there? Potentially. Powder like. What else? Caroline. Fluffy. What's the obvious? Its color is
White.
color is white. That's always important to indicate color. Richard.
It has a low density.
Has a low density. What do you mean?
It's not very high.
So we're gonna say it's not highly packed. Yeah, that's important because if you look at the pellets of calcium chloride, you can see space in between the pellets, right?
Yeah.
So I would say actually the baking soda is more dense.
It's higher dense than this, but in general. It's
More dense than the. Yeah, you're absolutely right. Andy, last one. What's that? Odorless. Excellent. Can anyone tell me what we just described? Think about describing matter what you looked at yesterday. What did we just describe about these chemicals? What did we describe? They're what?
Physical properties.
Excellent. They're physical properties. Can everyone write that on the side? Oh, I can spell. Physical properties. We just described their physical properties. Different chemicals have different physical properties. Along with their physical properties, they also have what? Chemical properties. We're not going to look at the chemical properties today, but we can determine different substances based on their physical and chemical properties. Everyone with me? All right, let's have some fun. First thing you need to do, it should take no more than 10 seconds, is to make sure that your scale is working. Just hit the power button, be patient and wait. Make sure it turns on to 0 and you have a little G in the corner for grams. Little G in the corner for grams. You'll be fine. If it is not working, we're very limited on the scales. You might have to use your partners as well. So make sure there's a G and zeros. Are you with me? Number 3, discuss how you can accurately find the mass of the chemicals. Use the Petri dish. We're not using the Petri dish, we're using the extra vial that does not have the red mark on it. And the zero out method by pushing the tare button. Can somebody tell me how we're going to zero out to find just the mass of our substance? We do not want the mass of the vial. Can somebody tell me how we're going to do that? Explain how you're going to do that, Ashley.
Put this on first.
Everyone pay attention. Yes, you put the cup onto the scale. It'll measure out 4 point something, I think. Hit the T-A-R-E button to zero it out.
It's not 1 point. It's like 1 point. Yeah, we're at 1.5.
I did the petri dish. I didn't do these. So make sure it's zeroed out. Ben, Ollie, are you with me back there?
Yeah.
You know how to zero out back there?
Yeah.
Cool. Just making sure.
Doing
Stay with number 4. Chemicals should not touch each other until they are placed in the Ziploc bag. That's important. They should not interact until they are in the bag and the bag is sealed. Once the chemicals are added, squeeze as much air as possible out of the Ziploc, seal it, and mix the contents gently before using your fingers. So we want to make sure that there's very little air in the bag to save room for something. You'll make that observation. 6, record all observations and reactions table in the following section, which is on the back. Complete the see, think, wonder during the activity. So throughout the activity, there's a reminder that see, think, wonder. Complete both. Observations and complete see, wonder, or the see, think, wonder. 8 is important. If you will receive a 0 if your bag pops. If your bag explodes, you will receive a 0. So how can we prevent it from exploding? Obviously, something's going to form in here. If it gets really, really pushing out the sides, just open it up. Let a little out, and then reseal it. Shake it up, it'll do it again. But any bags that explode will result in a 0. All right, haven't had any bags explode before. Hopefully today's not the first. So if it begins to swell, open the bag, and then seal it back up. Test 1 will be done by each group. We will explain this together in a second. You are responsible for completing 2 additional tests. Along with test 1, the 2 additional tests will be completed in the small Ziploc bags. I'm going to go over test 1 real quick. Flip it to the back. There are 10 different tests that you can complete. Of those 10, everyone is going to do number 1. Everyone will do number 1. The other 2 bags are on you and your partner. Whichever test, 2 through 10, you want to do, go for it. You will record your observations based on the test that you performed with your partner. Can you make a note that for number 1, instead of 5 grams of calcium chloride, you can use 15? Yeah. Instead of 5 grams of baking soda, you can use 15. The feel red and the water will stay the same. Only for number 1. Only, that's important. Only for number 1. Let me explain how number 1's going to go. You might do the same process with tests 2 through 10 as well. Remember, one of the rules were, or one of the procedures was, make sure that the chemicals do not interact before you touch, before you mix them. So I'm going to take, it says 15 grams of calcium chloride. I'm just going to do this quick. You're actually going to measure it out, right? Usually I'm just going to take it quick. I'm going to put some, this is really quick. I'm going to put some in the corner. That's not 15. You will put more. Nope, not doing it. Just watch me. I'm going to take this. I'm going to spin it. Twist it off. Okay? I'm going to take the baking soda and do the same thing. You're going to put a lot more, only 15 grams. Put it in the other corner. You're going to need 2 hands to do this. Both you and your partner. And I'm going to twist off this as well. Are you with me?
Yeah.
Okay? And the last thing you need is the 1 vial, which is the red, the one with the red. It means you put the phenol red in there. 1 vial of phenol red. You're going to dump it in there without mixing anything. You're going to carefully, one person holds it, the other person squeezes as much air out of it, seal it, let it go, mix it up. Something's going to happen, right? Remember, we do not want it to explode, right? So if it gets too big, especially in the smaller bags, obviously you're going to get some reaction in the big bag, but in the smaller bag, make sure you let some out, reseal it. Let some out, reseal it if it gets too big. Big bag might not get that unless your calculations are a little off. Okay, so safety goggles should be on right now.
They're on.
One thing you need to remember is your see, think, wonder throughout the investigation. What do you see? What are you thinking about? And what do you wonder?
We need 60.3.
Goggles.
Does it matter what kind of water it is?
Nope. You have less than 30 minutes to finish all 3 tests. Remember, test 1 goes into the large bag. The other 2 tests go in the small bag.
Wait, 15, right?
Yeah. Notice you have an observation section after the reaction occurs. What? What? Did I hard to follow? Huh?
That's
Did that set in order? So we're just measure out. Which one are you going to do? Are you doing this one first? So measure out 15. Time off. And then you're going to put your 1 vial of red up in the bag, seal it. Right? Yeah, so that's the direction.
Oh, no, one side.
Back there for water?
Push out one
So
side.
water goes in there. Remember, the X represents what is included in each test. Notice, make sure you feel, use that sense of touch for your observations.
I saw that.
Find this over here. It starts out and then.
Whoa. One vial. That's so crazy.
It's only that.
I said vial. How much red stuff do we put in?
Something being
Only stuff to like the right? Oh yeah.
So was one part of the observation. Remember, see, think 1 or 2, please. 15? Yep, so that's tied off. So you put the other into this one.
Wait.
What are we using that for?
Oh yeah, I know.
3, 2, 1.
That's all they got.
Yellow color.
I'm sorry? Yep, so you're ready to go now, pour it in.
Oh, which the Reynolds?
We're gonna seal it.
Take it.
Get all the air out. Keep sealing it. Completely sealed.
Okay, what do we see? Okay.
Let it go.
This
Mix everything together now.
yellow. Mr. Reynolds. It's hot. What was that? It's hot.
Is it warm? Now it's cold.
Whoa.
I don't like it right now. I don't like it. Feel this one. It's too warm.
Where do we write it down?
Make sure you do your observations.
Come on, do it again. Do it again. If you do it again, get out. Obviously. Yeah, we have way there. Where do we write it?
Okay.
Smell it. Smell it. No. The observation. What do we do with yellow?
It's yellow.